Hey, it's Miss Gill. I had somebody ask me a question about the end of the second packet. Uh, she asked me if I could give some examples on problems 5 through 12. So I think if I just do 5 and 6, that will show you how to do the rest of them. So if you remember the steps to these multi-step problems where they have variable terms on both sides, we used the acronym Davy Crockett Middle School, and that stood for distribute, combine like terms, move variable terms to one side of the equation, and then it's just a regular old two-step equation that you solve. So when I look at an equation, I don't look at it like the jumbled mess that it is. I look at it in its terms. So in this equation, when you have 4 terms, we have a positive 2.3, a negative 5x, then we have a positive 3x, and a negative 5.7. Those are your 4 terms in this equation. So the reason it's called solving equations with variables on both sides is obviously because there's an x on the left side of the equation and an x on the right side of the equation, and we're gonna have to keep this balanced as we solve it. So first step is distribute. We don't have any distribution in this problem or any of the other problems. I think you'll know distribution when you see it because you'll have a number outside of a parentheses like this. So that will tell you that you need to distribute the number in front of the parentheses. But we don't have any of that, so we're going to X that out. We don't need it. We're going to skip it. Next up is combine like terms. Okay, on the left side, I have a constant term and a variable term, so I can't combine those. On the right side, I have a variable term and a constant term, so I can't combine those either. So we're going to skip that step. Now we're on the third step, move variable terms to one side of the equation. So we got a variable term here and here. You can move either one that you want to. Like you could move this one over here or vice versa. You can move that one over here. I'm going to move negative 5x to the right side just because I think it's easier to move the smaller term. So negative 5 is smaller than 3x. But it'll work out either way. So in order to get rid of minus 5x on the left side, I'm going to have to add 5x. So to get rid of minus 5x, you have to add 5x. We'll clean that up a little bit. Get it back to the way it was. And if I do it to the left side, I have to do it to the right side. So the whole point of adding 5x was to get rid of the minus 5x. So these guys are going to cancel each other out. And then I'll just be left with the 2.3. I can bring it down. 2.3. Now on the right hand side, I've got to actually clean it up a bit. So I've got 3x plus 5x. That makes 8x. And the minus 5.7, you can just bring it down. There aren't any other constant terms to combine it with. Okay, so in blue there, I've done the third step, which was move variable terms to one side. So I only have a variable term on the right-hand side now. So now it's just a regular old two-step equation. So I'm going to isolate the 8x first by adding 5.7 to both sides. So those cancel out. So on the right hand side here, all I have is 8x. And on the left hand side, I forgot to say I was adding that. So on the left hand side, I'm going to have 8.0. That works out nice. Now I want to get rid of the times 8. To get rid of times 8, I have to divide 8 on both sides. Over here, I've got 8 divided by 8, which is just 1, and 1 times x is x. So I've got x equals, and on the left-hand side, 8 divided by 8 is 1. So that is my answer, my solution. X equals 1. But the directions say we have to also check ourselves. So I'm going to perform a little check over here. Also, I forgot to check where I did the last step. So I'm going to copy the original problem, except wherever I see an X, I'm going to plug in my solution. And hopefully the left side comes out to equal the right side, if we did it correctly. Plug in a 1 for X. Okay, then on the left-hand side, 5 times 1 is 5. That's pretty easy. Right-hand side, 3 times 1 is 3. Okay, on the left-hand side, I've got positive 2.3 and negative 5. If you remember the rap song, for different signs, you have to subtract. So here I would have to borrow 2.7. And since 5 is bigger, I have to keep the negative sign. Different, keep the larger. So does negative 2.7 equal, what do we get over here? Different sign, subtract again. 5.7 minus 3 would be 2.7. And since 5 is bigger than 3, we're going to keep the negative. So yes, it checks out. Alright, now let's try number 6 using the same steps. Okay, again, we don't have any distribution. I don't even have parentheses, so we'll just mark that out. Combine like terms. Let's see here. On the left-hand side, I have a variable term and a constant. That won't work. And then on the right-hand side, I have a constant term and a variable term. So there's no like terms that I can combine. We'll move straight into move variable terms to one side of the equation. So I've got a variable term here and a variable term here. I know it's written as x divided by 3, but I think of it like positive, oops, that doesn't look good. Positive 1/3 x. So hopefully that helps you a little bit. And this is positive 1/6 x. So again, it doesn't matter which one you move. I'm going to choose to move 1/6 x just because I think it's easier to move the smaller one. So the whole reason I did that was to cancel this out over here. So I won't have a variable term on the right hand side. I'll just have 5. Now on the left hand side, I've got 1/3 x minus 1/6 x. 1/3 minus 1/6. Well, since 1/6 is half of 1/3, I'm just left with the other 1/6. So I'm going to have 1/6 x. And the plus 4, I can just move it down. Okay, so I moved my variable terms to one side. Now I've just got to solve a regular old two-step equation. So I'm going to isolate the variable term by getting rid of the 4. So on the left, I just have the 1/6 x. And on the right, I've got 5 minus 4, which is... Alright, then let me extend my line a little bit here. To get rid of times 1/6, I'm going to divide 1/6. Divide 1. So over here, the times 1/6 and the divide 1/6 cancel each other out. You're just left with x. And on the right hand side, 1 divided by 1/6 is the same as 1 times 6. That's keep, change, flip. Keep, change, flip. I got 6/1, which is just 6. So 1 times 6 is 6. So my answer or solution is 6. Let's just check it really quick. Okay, so I'm going to copy the original equation, but instead of x, I'm going to put 6. So does the left side equal the right side? Our solution is 6. Okay, on the left-hand side, 6 divided by 3 is 2. And on the right-hand side, 6 divided by 6 is 1. 2 plus 4 is 6. Does 6 equal 5 plus 1, which is 6? Yes, it does. So it checks out. So that's how you do 5 through 12. Some of the problems are like number 6, where it's the variable divided by some number. Just think of it as a fraction times that number. So did I write number 7? No, I thought I did, but it had x over 8. So just think of it as 1/8 x. Alright, if you have any other questions, just let me know. Thanks. Bye.